All right, so we're back in part 3 of the video. If you haven't seen the first two, go ahead and go back and see part 1 and part 2. Okay, so we're learning a lot here, and it occurs to me that although everything is working right, so let's talk about our victories for a second, right? So the enclosure is working well, everything fit inside of it, no issues except for having to find some longer screws for the exterior fan. All the soldering went well, the electrical connections are good, the box works. The coolers are producing cold air. The only issue is that cold air doesn't seem to be going exactly where I want it to go, even after the addition of those tiny fans to blow the air up. So I think what I need to do is, if I can find a way, if I can design something to guide the air from those TE coolers exactly where I want it, not waste it going up into the box or wherever else. If I can do that, I think that might work a little better. So let's design something to make that happen. So here we are back in trusty old SolidWorks, and here's the little ductwork that I created. So it's nothing fancy, but if I designed it right, the TE coolers should fit right here on the bottom. I've got some legs here for with openings for all the wires and electrical work. And then of course the idea is that the fans will blow the cold air up and be guided out the front. So it'll come up this way and out the front. That's the idea. Let's see if it works. Here we are in trusty Cura, which is the program that we need to use so that we can send this to the 3D printer. Here's the representation of the little duct that I showed you a second ago. Here's what it looks like sliced and how it's going to print, just like this. Again, the light blue that you see right here, those are supports. You need those anytime that you have like a big window or hole in your print, and that'll help it print correctly. But here's what it's going to look like. All right, let's see how it turns out. All right, and there she is. So fit perfectly on top of the heat sink. It fit actually a bit snugly over top of the TE coolers and the fans, but everything went well with the fit. And then the wires also were a bit of a tight fit, but made it through. So here you see the end result. I also went ahead and I drilled 2 holes into the lid. So because I'm such a master designer and everything fit perfectly the first try, there really wasn't a lot of air getting into the box. So it was actually creating a bit of a vacuum when I turned that fan on. So I drilled these 2 holes as a way to create more airflow. All right, so lucky try number 3. Let's see if we can get a good temperature output here. So below high 60s would be desirable. 50s would be the best if we could get there. Here I am pouring in the ice. I did measure also how much water this thing held. 32 ounces is about the perfect amount. I chose this size for 2 reasons. One, I kind of wanted the thing to be compact. It's supposed to be a miniature AC. The second part is that I was limited by the build volume of my printer. So those are the 2 limits for the size here. It's a moment of truth here. Will the 3rd time be the charm? Fingers crossed. Okay, ambient temperature 72.8-ish. Let's see what the temperature is on the device. 60s, 50, 55, 59. Looks like it's working. Let's test again just to be sure. Okay, 71, 72, 73 degrees in the room. 53, 54, 55 degrees. Output. Perfect, we did it. So there we go, it works. Super exciting. It was definitely a little bit of a challenge to get working with those 3 revisions that we went through, adding a little bit more each time to get it working just a little bit better. But getting 55-degree cool air coming out of this little box in a 73-degree room, I can tell you standing in front of it, you could definitely feel the coolness. So that was very exciting. It's exciting that the duct idea worked and the fans worked, so everything worked perfect together. But I still think there's one more test that we have to do to see if this thing works practically. I'm not sure how much it will actually cool down the room, so let's test that. All right, so here's what we're gonna do. I have a 10-foot by 10-foot, pretty small room in the upstairs of my house. It's a little workroom that I have for these sorts of projects. And I'm gonna see how well this mini AC unit that I built can cool this room. So again, it's not a big room. What I'm gonna do is I'm just gonna put the mini AC unit on a table, and I'm gonna put a thermometer in the other corner of the room and just see how long it takes to cool down, how much it cools down. Let's see how it works. So here's a thermometer and here's a stopwatch I'm gonna use. I put them right next to each other so you can see how it changes over time. And you can see that the room right now is a blistering 76.1 degrees. Again, this is a later day than the other parts of my video. I shot this over a couple days, so that's why the ambient room temperature keeps changing. But here we go, we're gonna kick it off. All right, so after 1 minute here, you see that it's cooled down 0.6 degrees at 75.5, so that's encouraging, it's working. 3 minutes in, we're now at 75.3. 5 minutes in, 75.2, so just about 1 degree we've cooled down in 5 minutes. 5 more minutes, now 10 minutes has elapsed. You can see on the watch, we're down to 78.4. And then 5 minutes after that, at 15 minutes, 74.6. And we're gonna stop here at 15 minutes. Okay, so I stopped it at 15 minutes for a reason. Well, 2 reasons. Number 1, the temperature had stopped cooling, so I think I was kind of out of cooling power. And why was I out of cooling power? Reason number 2 is because I noticed that the ice had melted. So if you notice, I used about 1 pint cup full of ice. So, 16, 20 ounces of ice. I put that 32 ounces of water in there. And so with my system, with those constraints, it lasts about 15 minutes before all the ice melts and the water actually starts to heat up a little bit. So I measured it with another thermometer, and you could see the water temperature start to creep up from 32 degrees, which is ice water, 32 Fahrenheit, to 40, 50, 60, and that's that temperature differential closing that we saw before with these TE coolers. So that means that all the heat has been sunk into this ice water, and that if I were to keep the device on, it would no longer have a heat differential and it would no longer cool, so the experiment's over. So there we have it. We're at the end of the video. I think it turned out great, honestly. I'm very happy and very excited. So just using my little mini AC unit, I was able to cool down a pretty small but normal size bedroom for maybe a child or something, 1.5 degrees in about 15 minutes. So that's a fairly noticeable amount. It's definitely a measurable amount. I'm happy with that, and I'm happy with the project in general. This is why I do these projects. I'm excited, and I hope some of that excitement transfers to you as well. The reason that it's so cool is because we started with just the idea of physics. There was this theory in physics. It's the Peltier effect. Okay, and so some smart people built these devices using semiconductors called TE coolers. So we know that if we apply a certain voltage and a certain amount of current, we get this cooling effect. Okay, so we bought some of those, we tested it out, we figured out how it worked, and then we figured out a project to exercise that functionality. Then we designed this enclosure, and through the magic of 3D printing, that idea in my head became a physical reality. Very cool. We put it all together, we soldered it together, tried it out, and sure enough it worked, but not perfectly. So we got to troubleshoot. And that's what we do as engineers. We're technical problem solvers. That's why I got into engineering. So then we had to go through these iterations of, is this going to work to solve it? Is that going to work? And everything we did helped a little bit till we got to our third revision, our third little tweak that made the thing work. So this little project that we made, it's not as good in many ways. It's not as efficient as just a normal AC unit in your house or window unit or in your car. There's a reason that the very smart people that design these AC units that use evaporative refrigerants in them to cool, there's a reason they didn't use TE coolers. They're very smart people, right? We learned in the first video, and we knew from the first video, that these TE coolers are not efficient for this purpose of heating and cooling a room, for example. They are very good for heating a beverage, for heating a seat in your car perhaps, or something like that. So they have their uses. I decided to use them for a purpose that they're not the best fit for. Okay, no problem. But it did work. And so I think future improvements, if I were to do this again, what I might do is I might create a little bit of a bigger unit. I might use a standard cooler that held, let's say 64 ounces or maybe even a gallon of water, 128 ounces. So make it a little bit bigger, maybe even put 2 or 3 more TE coolers in there to increase the cooling capacity. And then with the more ice and more water, it would also last a little bit longer. So maybe if I did that, maybe I could cool down that same size room by 3, 4, 5 degrees. So anyway, that's a thought experiment. I don't know that I'll ever do that, but I think we went ahead and did what we set out to do. All right, friends, so with that being said, that is our improvement for today. We finished a cool project. I think it turned out well. Hopefully you enjoyed watching as much as I enjoyed constructing this project and recording it. As always, thanks for watching. See you next time.